Okay, so in here let's just look at on compound microscope and telescope because last it was question in 2022. So we are having some amount of possibility on that. So before we just go for the ray diagram of it, we must get a clear understanding of these adjustments. So we are having two adjustments named as normal adjustment and non-normal adjustment. So what is the main difference between these two is when it comes to compound microscope, at normal adjustment, the image is formed as the least distance of distinction. It might be 25 or anything, but mainly you should understand when it is in the normal adjustment, the image is produced at the least distance of distinction. And when it comes to the non-normal adjustment, the image is formed at infinity. So these are the main difference between a compound microscope adjustment. When it is come to the normal part, image is at the least distance of distinction, whereas in the non-normal, image is at infinity. But it's quite different when it comes to telescope. It's actually the shift of these two, where during the normal adjustment in a telescope, image is produced at infinity, and during the non-normal adjustment, the image is produced at the least distance of distinction. So these are the key difference which you should know before we just proceed to the ray diagram part. Okay, so let's get an idea about the ray diagram for a compound microscope and a normal adjustment. And you should understand there are main difference which you should note down. So when it comes to telescope, we used to focus on far objects. So under that scenario, there will be parallel lights towards the objective lens. But when it comes to a compound microscope, actually the object will be at some distance. So every time it is at a certain distance, and it is getting subjected to the compound the objective lens. So when you're just drawing the ray diagram, you don't need to have a certain scale, because you know that when it is in a normal adjustment, the final image, that means this object is getting subjected to the objective lens, and there's image created in this section, and that image will act as an object for him, and again there will be a final image produced. So you should understand the image created by the eyepiece is gonna be a virtual image, and when it comes to a normal adjustment for a compound microscope, it will be at the least distance of distinction. So anyways, my final image should be produced at the least distance of distinction. So make sure to just get an idea about, okay, where are the images are. So you can see that a real object forming a real image when it is subjected to the objective lens. So the first image is being produced at here, and you should understand it is erect. So let's get an idea, okay, it must go through the focal length. So then when it is going through this, it must exactly meet here. So first of all, make sure to have a clear diagram on where the first image is getting formed. So a parallel ray is going through the focal point, then through this, where these two intersect, there is the location of the first image. So you should understand, now this image will act like an object for this lens, producing a virtual image. So when it comes to normal adjustment, it will be at the least distance of distinction. So anyways, my final image must be around here, and it must be quite magnified compared to him. So when you are doing the next case, the ray is getting subjected to here. Make sure to mark the arrow directions. So you should understand, eventually my final image must be around here. So just draw the dotted line from this section, from the final image towards this ray. And also just deviate it according to that dotted line. So there was this ray. It is getting subjected to the eyepiece. So you should understand, I have already drawn my final image. So I just connected the dotted line towards that ray and I bend that ray as according to the dotted line. So this is the most key point you should understand. Instead of deviating that and finally getting the image, the best thing you can do is, of course, when it comes to a normal adjustment, it is at least distance of distinction. So just have a virtual image and according to the dotted line, you can just deviate it. So if you just look at this ray, it is getting to this point. So when this ray is, when a dotted ray is drawn from this onto this, just draw a dotted ray, it should deviate according to the dotted ray pattern. So from this easy method, you can actually draw a proper ray diagram with a minimum amount of time. So here you are having the first image and here you are having the second image. And we used to observe this from the eye placed at here. So this is the simplest ray diagram for compound microscope under normal adjustment. So whenever there is a question to draw the ray diagram, we are also supposed to find the angular magnification. So you should understand the basic equation behind angular magnification is angle subtended in the angle subtended on the unaided eye over angle subtended on the eye when it is used with a microscope. So I'll just come to that in a while. So let's get a derivation of the magnification. So you should understand so when it comes to the magnification part, when it is in the normal adjustment, we can consider the magnification of this created by this lens and the magnification created by this lens separately. So the magnification created by the objective lens is, let's say, m0, and the magnification created by the eyepiece, let's say it has me. The product of these two would get you the total magnification. So we must understand the magnification created by a lens is actually the image distance over the object distance, which is also equal to the image height over the object height. So yeah, let's get an idea about this. So anyways, you know that the image produced by the eyepiece is at the least distance of distinction. So we actually know the image created by him, which is at a distance of d, but still we don't have an idea about the object distance. Let's say it has u1, okay? And you should understand it is placed at a certain distance, let's say u0, and the image is being produced at here. So let's say it has v1. So actually we must get an idea between these v1, u0. Now having d in the answer is not a problem because actually we know an answer for d. It is a least distance of distinction. But we actually don't know what is v1, u0 and those stuff. Because from person to person this used to change. So let's see how to do this. So let's work on this step by step. You should understand. Let me write the sign about lens law for this guy. You'll be having 1 over v plus 1 over u is equal to 1 over f. Now since I didn't use the sign convention because you can see that there's a real image produced for a real object distance and it is a convex lens. So we are having 1 over v plus 1 over u is equal to 1 over f. So if I want to find v over u, we must multiply the entire equation by v. So I would actually find it as 1 plus V over U is equal to V over F. So eventually we are able to find the magnification created by the objective lens. So M naught will be equal to, it is around V over F minus 1. So according to the question, you might get an idea about that, because if the object distance is given, it's better to multiply by the object distance. So depending on the question, you must take a decision, right? And yeah, if it is an essay question, they might say the lens separation is around a certain value. So if this one is let's say 80 centimeter, if the object distance is 20, the remaining 60 will be the object distance for this guy. So you must know these logics as well. Similarly, let's find the magnification created by the eyepiece. So we know that 1 over V, as you can see here, there's a real object, but there's a virtual image being created. So you actually have 1 over V minus 1 over U is equal to minus 1 over F. Just no more this lens formula, because in here you had a real image, but the image produced by him is a virtual image, and it is at the least distance of distinction. So 1 over D minus 1 over U is equal to minus 1 over F, and we know that image distance over object distance will get you the magnification. So I'll multiply everything by D. So eventually I will be having an answer around 1 minus D over U is equal to minus D over F. So my magnification by the objective lens is going to be 1 plus D over F. So we know the magnification created by the lens separately. It's from the, okay, sorry, mistake. It is from the image eyepiece, okay. So from the objective lens we have 1 over, okay, V over F minus 1. And from the eyepiece we are having 1 plus D over F. And we know that the total magnification is equal to M naught times ME. So we must actually multiply these two magnifications. So my answer will be around V naught over F naught minus 1 over D over Fe plus 1. If it is not clear, just go to the website again. In the website I have just uploaded the relevant equation. But actually the ray diagram is really crucial. And whenever they just give you a ray diagram, they might ask you to find the relevant magnifications. If it is an essay, they'll be asking to find it separately, then the total magnification. Or else you can, even they ask the total magnification at once, you should get an idea. If it is in normal adjustment, the magnification created by each lens can be multiplied to find the total magnification. So I think in the upcoming video I'll just upload for the next case a compound microscope in non-normal adjustment. So it is quite easy, okay, because the only thing is image will be produced at infinity, which means you don't have an image at this location because the image is produced at infinity, which means these two rays will diverge parallelly. So let me just add that video onto here itself. Okay, so this is the easiest ray diagram to draw. You should understand when it is in the non-normal adjustment, the image is at infinity. So we no need to draw a virtual image here because the image is found at infinity. But we anyways know that the image produced from the objective lens is real. So we have a real image here. So let's set up that. So draw a parallel ray, it goes to the focal point and then just go to this. The intersecting point will get you the image created from the objective lens. And now the most important point, as again the rays are going to meet the eyepiece. The rays are going to meet the eyepiece. the thing you should understand is we are having a virtual image. So if we just move through the previous part, they started deviating, and when their lines of actions were extended, when their lines of action were extended, they met at a certain point. That's why we are able to say there is a virtual image created. But you should understand, here there is no image produced because the image is produced at infinity. So if you have thorough experience on them, for an image to be produced at infinity, they must be parallel rays, right? So they must deviate parallel to each other. So when they deviate parallel to each other, you never have an intersecting point. So very in a smooth way, you can just draw these diagrams. If you are having the normal adjustment, make sure to intersect them. That's why I say draw the image first. But non-normal is quite easy, okay? You must bend them in a parallel way. So they never gonna meet again. So actually the ray diagram of this is fine. It was question actually in 2022. And of course, whenever there's a ray diagram question, they'll be asking you to derive the magnification part. So as I said, only for normal adjustment, we are going to use individual magnifications product as a total magnification. But when it comes to this case, we must find the logic which I said. So I said that the total angular magnification is equal to magnification created by the unaided eye, first thing. So the angle subtended from the unaided eye over angle subtended on the eye from the image from by the microscope. So you can see the eye is placed at this location. So we must actually get an idea about. Okay, so the thing you should understand here is, now there's a real image produced by the objective lens, but there's a virtual image created by the eyepiece. You can see there's a virtual image. So I have just said this. If you want to form a virtual image, of course, you must place an object at the focal point of the lens. Then when it is placed at the focal point, you will be having a virtual image. Now you can see the virtual image is created by this lens. It's not by him. So you should understand, then the object is placed at the focal point of the eyepiece. That's the thing you should understand when it is in a non-normal adjustment for a compound lens. Okay, and yeah, let's say the height of him as h dash, and you can see it is going through this. Let's say the angle of him, let's say beta. So this is the angle created on the angle created on the eye by the image from by the microscope, since it's a virtual image. Because you should understand, even if you draw it this way, it will be parallel. Okay, so actually tan beta is equal to h dash over fe. So the reason we obtain tan is, of course, we know only two parameters. One is h dash and other one is fe. And we can approximately say that tan beta is equal to beta, which is h dash over fe. So we must understand this beta represent the angle formed by the eye by the image created from the microscope. So if you want to find the total magnification, we must also find the angle created on the unaided eye. So this is our eye. So we are not using any equipment. We are just focusing on the object. So you should understand, anyways, the height of the object is h, okay? Its natural height is h. So when it is subjected to a convex lens or a concave lens, there will be this change in height. So you should understand, what is the angle created in the unaided eye? What is the angle created in the unaided eye? Let's say it as alpha. So beta is the angle created on the eye since you are using the equipment, so without any equipment, what is the angle? Let's say it as alpha, and we must understand it's clearly visible only we place it at the least distance of distinct vision. So only when you place it at the least distance of distinct vision, you are able to see that. Now make sure to understand this, okay? Because when it is in the normal adjustment, actually in our expression, in our ray diagram itself, there was this least distance of distinct vision. But we must understand when it is in a non-normal adjustment, only by the concept, okay? The angle subtended on the unaided eye, we get this least distance of distinct vision. So if I again obtain an expression for tan alpha is equal to h over d, which is approximately equal to alpha, because these angles are actually small, okay? That's the main assumption. So we know that the angle subtended when using the equipment, or the angle subtended on the unaided eye will be your total magnification. So it is actually h dash over fe divided by h over d. So let me just write it as, h over d. Now still you are not over, because we have only obtained an expression between an expression like this. Now usually they never give you the height of the images. So let me just write this in a brief way, like h dash over h is h dash over h into d over fe. So we must understand that h dash over h dash over h. So when it comes to this lens, you are subjecting an object with a height of h. Because of that, there was an image produced. The height of that is h dash. So the ratio between image height and the object height is actually the magnification created by the objective lens. I said in the previous part as well. You can also consider image distance or object distance. Also from the height you can obtain that idea. So let me obtain an expression for this magnification created by the objective lens. Now I'm not gonna waste any time, because we know the lens formula now. 1 over v plus 1 over u is equal to 1 over f. Even in detail we had around v over f minus 1. V over f minus 1 as the magnification created by the objective lens, which you can replace in terms of h dash over h. So my final expression would be v over f minus 1 into d over fe. So I think the ray diagram of this is quite easy, but the derivation part will look a bit messy. So just go through this again. Just remember the basic equation. Angle subtended on the eye when using the equipment over angle subtended on the unaided eye. So we actually obtain tan expression. Now some might have confusion. Why I just draw a ray like this? Because as you know that you are having a virtual image. So you should understand if I draw the separate ray diagram for this part, you can see you are having the eyepiece. You are having the virtual object, okay? Because that virtual object, you are having an object here. The image of this guy is the object for him. And the image produced by this object and lens combination is at infinity. So if I just draw, it will be like this. Where these two are parallel rays which they never meet. Okay, so that's the reason why I just do this. Even drawing this part is parallel to these two sections. They are never gonna meet. So that's gonna be the angle produced here, beta. So just remember that part. Okay, so in the next video series I'll just upload for the astronomical telescope, but mainly go through this since compound microscope is in question for a long time. And yeah, the equations behind this is uploaded in our website. You can just check on that. And if you want, you can just figure out the difference between these two. For normal adjustment, we had d over fe plus 1 apart from this section. Only difference is we are having d over fe. Okay, thank you.